Okay, sketching graphs using transformations. So as we get going on this, we want to sketch the graph of the reciprocal function, so the 1 over x function that has been shifted 2 units to the left and then 3 units up. So to get going on this, I'm going to break this down into individual steps as we go. The first graph we'd like to graph is 1 over x. So this is one of our typical reciprocal functions, one of these rational functions. This is the one that has points at 1, 1, and -1, -1. So I'm going to kind of track those around. Hopefully we recall that this also has a horizontal asymptote and a vertical asymptote. A horizontal asymptote going across at the x-axis and a vertical asymptote at the y-axis. So it's not going to be a perfect sketch, but it's going to start out and look basically like this, and it does go up as it approaches the y-axis on the right-hand side and goes down as it approaches the y-axis on the left-hand side. At the extremes, the end behavior gets very close to the x-axis. All right, so we wanted to move this to the left 2 units. So the next graph I'm going to graph is 1 over x plus 2. And the instructions here are this is going to move everything to the left 2 units by attaching a number directly to the x. It's going to be a left or right shift. In this case, it is going to move everything to the left 2 units. So the first thing I'm going to do is I'm really just picking up this graph, the 1 over x graph, and moving it 2 units to the left. But I'm going to track around our vertical and horizontal asymptotes as I do this. So when I had a vertical asymptote at the y-axis on the left graph, that's going to get picked up and moved to the left 2 units. So I'm going to identify it with a dashed line now that it has moved off of the axis. Typically, the axis is more important than the asymptote itself. So now we have a vertical asymptote at -2 and a horizontal asymptote at the x-axis. So you can kind of line up these points, and the entire graph is going to shift over 2 units to the left. So it's not perfect, but you use your best imagination to imagine that I just picked up the graph, moved it over 2 units, and set it back down. Should look like the exact same graph at the left-hand side, picked up, moved over 2 units, set back down. Next, what we want to do is we want to finish this up by moving everything up 3 units. So we're going to attach a number to the entire function. So it's going to look like this, where we have a +3 attached to the entire function. Now, that's not going to move our vertical asymptote, so I'm going to sketch that back in at -2. Dashed line going up here at -2. But now it has moved everything up 3 units. So we had a horizontal asymptote at the x-axis. That's going to move up to 3. So I'm going to go ahead and sketch that in with a dashed line now that it's off the axis. And then just be careful. We're supposed to pick up this entire graph, pick it up, move it up 3 units, and set it back down. So I like to track around these 2 points. One's kind of like up 1 and to the right 1 of where these asymptotes meet. One's down 1 and to the left 1 of where these asymptotes meet. Sketch the rest of our graph in. Do our best with that, make it look pretty nice. And that's a pretty good finished graph. Now to finish this up, we should probably identify where are our vertical and horizontal asymptotes. So our vertical asymptote, we moved it to the left 2. So now it's going to be at x equals -2. And then our horizontal asymptote, that got picked up and moved up 3. So that's going to be at y equals 3. Make sure you include x equals and y equals, as these are equations of lines. All right, let's try one more of these. This time through, we are going to be using, we want to sketch the graph and find the horizontal and vertical asymptotes of the reciprocal squared function. So our starting function is y equals 1 over x squared. And we want to move this to the right 3. So our next one will move to the right 3. And then finally, we'll move everything down 4 units to conclude. All right, so the 1 over x squared graph, let's start with that. Hopefully one of these basic ones we're getting down. That was the one where they were both in quadrants 1 and 2. If you were sketching this. So we had a vertical asymptote at the y-axis again, and a horizontal asymptote at the x-axis. But this time, instead of quadrants 1 and 3 like our previous example, it's quadrants 1 and 2. So next, let's attach in some numbers, move us all to the right 3 units. So a number is going to get attached directly to x. So we're going to say x with a 3 in there, and this is moving to the right 3 units. So it's kind of counterintuitive. We're going to subtract 3 directly from x, and it's still going to be squared, just like the x was squared here. It's going to be the quantity x minus 3 squared to move everything to the right 3 units. Next up, we're going to pick up that vertical asymptote that was at the y-axis, move it over 3 units, and it's going to land at 3. Positive 3 here. So I'm going to sketch that in using a dashed line now that it's been moved off of the axis. And I'm going to kind of locate a couple points here. Up 1, right 1, from where these horizontal and vertical asymptotes meet, and up 1, left 1, being an additional point on the left-hand side. Do our best to get a nice sketch going. Still getting close to the x-axis, but also getting close to that vertical asymptote going across there at 3. All right, to finish this up, one more transformation needs to be done. We need to move everything down 4 units. So we're going to bring along what we do have, the x minus 3 quantity squared, but then attach -4 to the entire function. Vertical movements, we always attach a number to the entire function. Those work how we think they should, with addition or subtraction. For left or right movements, horizontal movements, we attach a number directly to x. Those kind of work the opposite of what we think they should. They're kind of counterintuitive as far as the sign goes. All right, so let's sketch in our vertical asymptote at 3. And now our horizontal asymptote is moved from the x-axis, got picked up, moved down 4 units. So it's going to be at -4. Again, a nice dashed line should be utilized for that now that it's off the axis. Again, locate a couple points, up 1, right 1, up 1, left 1, from where these asymptotes intersect. And then get a nice sketch going with our graph. Hopefully that makes sense, that I'm really just picking up that previous graph, moving it down 4 units and setting it back down. All right, finally, let's go ahead and identify our vertical asymptote. It looks like since it had been moved to the right 3, it'll be at x equals 3. And our horizontal asymptote, we had moved everything down 4 units, so that's going to be at y equals -4. All right, I hope this helps you as you're working with transformations with rational functions to get very nice graphs without too much heavy lifting as far as like finding a bunch of ordered pairs on our graphs. Basically, you're concentrating on the vertical and horizontal asymptotes, moving those around, and then picking the rest of the graph up to go with it. All right, I hope this helps. Good luck.